Hello and welcome to the video for our AP Calculus AB Unit 2 test remediation. So let's go ahead and get into this one right here. We have our given function and we want to know the value of the derivative when x equals 0. So with this function that we have, we can use our sum and difference rules with our derivative. So let's go ahead and find the derivative with respect to x. There we go. So f prime of x, all right, so 3 sine x, we know we can just say 3 times the derivative of sine x, which is cosine x, plus 8 times the derivative of e to the x, which is e to the x. So for f prime at 0, we've got 3 times the cosine of 0 plus 8e to the 0. And cosine of 0, we need to know from our unit circle that is equal to 1. And e to the 0, we need to know that as equaling 1. So 3 plus 8 equals 11. All right, with this one right here, this one is very important of reading all of the information that's given and being able to look at, all right, what exactly is it asking me to do? What exactly is it asking me to solve or to show? So we do have some pertinent information. These first two sentences here give us some information about the graph, but it's asking us, you know, how many values do these two equal? For how many values of C? All right, so here's A, here's B. For how many values of C in between A and B is this statement true? Is this equation true? And what we need to do here is recognize this as the derivative. The left side is the derivative or the slope of the tangent line. And the right side is the slope of the secant line. So for how many values does the slope of the tangent equal the slope of the secant? Now there's something visual here that should make it jump out at you so you can get your answer here. We know where we transition from decreasing to increasing, or where we transition from increasing to decreasing, anywhere we have a local maximum or a local minimum, the slope of our tangent is 0. We have a horizontal tangent at those 4 places. But what else do we have? Well, also at those 4 places, the slope of the secant equals 0. So that's one of those understanding, again, what each statement on the sides of this equation mean and being able to interpret what it comes out to as far as translating it. So in 4 places at each one of those transition, at each one of those local maximum, local minimum. But also I want to point out right here, we've got to remember we cannot take the derivative at a sharp point. So there is no slope of a tangent at a sharp point. All right, we have this differentiable function. We're given these different values. We want to know what is g prime of 2. We need to recognize this as we got our product rule going on here. So g prime of x is going to be, and now we're going to have to change our language a little bit because the way I learned and the way in most books, when it comes to the product rule, it's f prime g plus fg prime. But we're trying to find the derivative of g, and f is in the place of where g would normally be when we're talking about product rule. So let's look at it as first and second. So the derivative using the product rule, we want the derivative of the first function. So the derivative of x cubed is 3x squared times the second function plus the first function times the derivative of the second. And we're looking for g prime at 2. So g prime of 2 is going to be 3 times 2 squared times f of 2 is 2 plus 2 cubed times, and f prime of 2 is 5. So that's 3 times 4 times 2 plus 8 times 5 gives us 24 plus 40 equals 64. All right, nice fun little problem there. All right, now with this one, we have the graph of the linear function f and linear function g are shown, and we have h of x being f of x, g of x. We want to know what is h prime of 4. All right, a couple things going on here. First of all, h prime of x, again, we got our product rule, so it's going to be f prime g plus f g prime. And h prime of 4 is going to equal f prime of 4 times g of 4 plus f of 4 times g prime at 4. Well, the thing is, we're dealing with linear functions. So the derivative is just going to be the slope. So we've got, let's look at the slope of f. The slope of f is, well, it looks like we've got 1 to 1. So the slope of f is 1. And the slope of g let's see here, 1, 2, 1, 2, 3. We have a rise of 3 and a run of 2, so 3 halves. All right, so giving us h prime of 4 is going to equal f prime of 4 is just going to be 1. G of 4 is 1 plus f of 4 is 2, and g prime of 4 is 3 halves. So 1 plus 3 equals 4. 1 times 1 is 1. 2 times 3 halves is 3. D, once again. Okay. Now, we've got a rational function, which means we're going to use our quotient rule. So let's go ahead and write our quotient rule. That's going to be, actually, no, I'm not going to use f and g. I'll use numerator and denominator. So we got the derivative of our numerator times our denominator function minus our numerator function times the derivative of our denominator function divided by our denominator function squared. So already it looks like we can rule out C. And it looks like we can rule out A and D, but let's check just to be sure. All right, so this gives us for our numerator negative sine x log x minus cosine x divided by natural log of x squared. Now in this numerator, well, we have a subtraction here, but we don't have the same denominator. So we need like denominator. So that gives us negative x sine x natural log x divided by x minus cosine x divided by x all of that divided by natural log x squared. And now that we have a common denominator in our numerator, we can push that common denominator down and just be left with a one-line function in our numerator, overall big numerator that we've got here. So we can write this as negative x sine x log x minus cosine x, all of that divided by x, log x squared. And indeed, that is our answer choice B. All right, we have a differentiable function. Again, we are given some values here, and what G is defined by. We want the value of G prime at 8. And look at what we have here. We've got another quotient, another rational function. So we're going to use our quotient rule. So G prime of x is going to be f prime, or numerator, the derivative of our numerator, times our denominator minus our numerator function times the derivative of our denominator function. So let's go ahead and write, we have x to the 1/3. Let's see, we've got, let's just call it h. So h prime is going to be 1/3 x to the negative 2/3, which is 1/3 x, make this look better. One over 3x to the 2/3. All right. So that's f of x and all of that divided by cube root of x squared. All right, so that's G prime of x. That's the derivative of G with respect to x. Now let's find what is G prime of 8. All right, so we have f prime of 8 is 5 times the cube root of 8 minus f of 8 is 2 times 1/3 times 8 to the 2/3. All of that divided by cube root of 8 squared, which is 8 to the 2/3. All right, and I guess now I can point out, notice this is not a calculator question. All right, so let's look at this here. We got cube root of 8 is 2, so we have 5 times 2 minus 2. Now, I want to do this here. We have 8 to the 2/3 is equal to 8 to the 1/3 squared. And 8 to the 1/3 is 2. So that's 2 squared. So 8 to the 2/3 equals 4. So that's 5 times the cube root of 8 minus 2 times 1/3 times 4. So 2 times 1/12 divided by 4. All right, because again, we got, this is the cube root of 8 squared. That's the same expression we have here. So all of that divided by 4. So that gives us 10 minus 1/6 divided by 4, which is going to equal, let's do some magic here, abracadabra. That is going to equal 59/6 divided by 4. Hopefully you realize what I did there. And now we can push this denominator down, and that equals 59/24. The answer is A. All right, this one here, let me go ahead. For this one, Differentiability implies continuity, but continuity does not imply differentiability. What was the point of saying that? Well, let's look here. All right, g of x equals 2 minus 2x. We want to see what happens when x equals 1. Is our function continuous? So g of x for the top, we got 2 minus 2 times 1 equals 2 minus 2, which equals 0. So at 1, for the left side, we're coming in hot. And it's equal to 0 when x is 1. Now let's look at the other side. 5 times 1 minus 5 equals 5 minus 5, which equals 0. So our function is continuous when x equals 1. And there's something I should have done here. Let's see. We have an open circle there. And then on the other side, and see we had a slope of -2. Now we're going to have a closed circle and a steeper slope, a slope of 5. So it is continuous, but remember what I said a few questions ago, or a few problems ago. We cannot take the derivative at a sharp point. And that is a sharp point. So we need to go back and remember in one of the videos where we were looking at the absolute value function. And because our absolute value has that sharp point, that V shape, we cannot differentiate there. So this one, g prime of 1, the derivative at 1 is non-existent. Okay, now for this one here, we've got a graph of a function, we've got a table for the function. Let's look at this. We want to approximate the value f prime at 5.5. All right, so this one we got to remember, we can approximate, all right, approximate the derivative, the slope of the tangent, by looking at the slope of the secant. And the thing we want to do here, we want to use f of b minus f of a divided by b minus a. And I don't remember if this one said we're allowed to use the calculator or not. But anyway. Now, so we want to use, since we try to approximate the value at 5.5, we want to use f of 5.5. That looks way off. All right, that's better. Minus f of 5 divided by 5.5 minus 5. Now, what happened on the original test is a lot of, well, this is a different question, but it's set up the same way, where we had the function was defined on both sides, all right, but we had a jump discontinuity. And our function, we had the open circle, and then it picked up with the closed circle. We do not, well, anyway, a lot of people use the function value down here, or for the closed circle portion, but that is not relevant to this part up here. That is why we do not want to use f of 6. We want to use our f of 5.5, because we're looking at this portion right here, so we don't want to count that other part of our piecewise function. So this is going to give us 5.5. We've got 3.244 minus 3.455 divided by 0.5. Okay, so I just checked. This one was a non-calculator question, so we can just leave it at this right here. It says approximate it and show the computations. These are the computations that lead to our answer, and what they're looking at is that we're using the difference quotient, or not difference quotient, but using our definition of the slope, and that we are not using this point down here, but that we're using both of our points that we're picking are near the point where we're looking for our slope, and they're on this part where we're defined on this part of our piecewise function. All right, part B, is there a value such that this statement is true, and give a reason for your answer? And so first part of that answer is yes, there is a value. Now let's go back because I have it shown here. It says we have the graph of the function, table selection. It says the graph of f has a horizontal tangent at x equals 4. All right, so that is relevant information. And we need to interpret this as that is our tangent. That is our derivative. So what we want to say is we were given, I'll do it this way. I want to do a stick now. Let's do text. No. All right, so we want to, how do I do? Oh, yeah, click on this up here. And we want normal, okay. I'm getting it together here. All right. We were told there is a horizontal tangent at x equals 4. The given limit statement is the definition of which is the slope of the since there is a horizontal tangent, that let me say at x equals 4. All right, so we were told there is a horizontal tangent at 4. That given limit statement is the definition of the derivative, which is the slope of the tangent line. Since there is a horizontal tangent at x equals 4, the limit at x equals 4 is 0. All right, now for this one here, each of the following limits going to explain, find the value or explain why it does not exist. All right, so our first one, we're looking at the limit as h approaches 0. All right, we got to be very careful there. Not as x approaches 0, but as h approaches 0 from the right. And so we're getting closer and closer to x equaling 6. All right, again, we got our limit statement, our definition derivative there. So from the right, we see we have a straight line. And that straight line has a slope of 1/2. So since we have a slope of 1/2, that limit equals 1/2. And again, just to be clear, we want to say that is the slope of that linear portion. And of course, that is a negative slope there. Okay. And for our next part, let's look at this here. Again, what are we approaching? The limit is what are we approaching? And if we approximate, see if I can get it, if we approximate what our slope is right there, Let's see. No, that's not a good approximation there. It's going to be more so. Almost had it. It was close. But anyway, it looks like our slope, our numerator, well, we can say that does not exist. And why not? The numerator approaches the numerator is approaching 2. But the denominator approaches 0 because we're not defined there. And then for the last one, that limit does not exist. And we have 2 reasons why it does not exist. So we can pick either one of these 2 reasons. The left limit does not equal the right limit. I'm using a little bit of shorthand here. You would want to, on a AP test, we'd want to write this all out all the way. The left hand limit does not equal the right hand limit as h approaches 0. Or the other thing we could say that there is no, the limit does not exist there. Again, that is the definition of the derivative, and we don't have a derivative there because we have a jump discontinuity. And again, I'm writing this a little bit shorthand, jump discontinuity, so no derivative. There. And I do believe that is it for this video.